The James Webb Space Telescope is the most powerful observatory ever built. It cost $10 billion. It sits 1 million miles from Earth, and it can analyze the atmosphere of a planet from 50 light-years away. Researchers proved this in 2023 when a team showed that if Webb were pointed at Earth from a distant star, it could detect not just signs of life in our atmosphere, but signs of civilization. Oxygen, methane, water vapor, and even human-made chemicals like CFCs, the kind of industrial pollution that only a technological species would produce. Webb can literally smell a civilization from another solar system. So here's the part that should keep you up at night. Webb has now been scanning the cosmos for over 4 years. It has studied the atmospheres of exoplanets, peered into the chemistry of distant worlds, and mapped galaxies from the edge of observable time. And so far, nothing. No biosignatures confirmed, no technosignatures detected, no signals, no signs, no evidence of anyone else out there. The most powerful eye humanity has ever opened is staring into the universe, and the universe is staring back in complete silence. This is a story about what that silence might mean. The question isn't new. In the summer of 1950, physicist Enrico Fermi was walking to lunch at Los Alamos National Laboratory with 3 colleagues, Edward Teller, Emil Konopinski, and Herbert York. They'd been chatting about flying saucer reports in the news, joking about faster-than-light travel. Then, in the middle of lunch, Fermi blurted out a question that seemed to come from nowhere. According to Teller, the question was simply this: where is everybody? Everyone at the table immediately understood what he meant. He was talking about extraterrestrial life, and according to York, Fermi then rattled off a series of quick calculations: the probability of Earth-like planets, the probability of life given the right conditions, the likelihood of intelligence, the rise of technology. He concluded that, mathematically, we should have been visited by alien civilizations long ago, many times over. But we haven't. And that gap between what the math says should exist and what we actually observe became one of the most famous unsolved problems in science. They call it the Fermi Paradox. To understand why this silence is so strange, you need to see the numbers. In 1961, astronomer Frank Drake created an equation to estimate the number of detectable civilizations in our galaxy. It accounts for the rate of star formation, the fraction of stars with planets, the fraction of those planets that could support life, the fraction where life actually develops, the fraction where intelligence evolves, the fraction that develops technology, and how long those civilizations survive. Even with conservative inputs, the Drake equation suggests there should be thousands of active civilizations in the Milky Way alone. Some estimates go into the millions. And remember, our galaxy is just one of roughly 2 trillion galaxies in the observable universe, each containing hundreds of billions of stars. Many of those stars are billions of years older than our Sun, meaning any civilizations that arose around them would have had a massive head start. Even traveling at a fraction of the speed of light, a civilization could colonize the entire Milky Way in just a few million years. That sounds like a long time, but on a cosmic scale, it's nothing. The galaxy is over 13 billion years old. So where is everybody? Where are the signals? Where are the megastructures? Where is the evidence of anyone having passed through? The math says the universe should be teeming with life. But every instrument we point at the sky tells us the same thing: silence. Now, Webb did find something on a planet called K2-18b, and it's worth talking about because it shows just how difficult this search actually is. K2-18b is a sub-Neptune exoplanet about 120 light-years away. It sits in the habitable zone of its star, meaning it could theoretically have liquid water on its surface. In 2023, Webb detected methane and carbon dioxide in its atmosphere, which got scientists excited. But the real headline came in 2025, when a team at the University of Cambridge reported a tentative detection of dimethyl sulfide, or DMS. On Earth, DMS is produced almost exclusively by marine phytoplankton, It's a biological molecule. Finding it on another world would be, in theory, one of the strongest pieces of evidence for life we've ever had. But the detection was only at about 3 sigma confidence. In science, you need 5 sigma to claim a definitive discovery. That's a 1 in 3.5 million chance the data is a fluke. 3 sigma is much weaker. And when other teams reanalyzed the same data independently, they couldn't confirm the DMS signal at all. One team at Oxford found the evidence didn't hold up. A NASA-led reanalysis found the signal fell even further, to about 2.7 sigma. So what happened? The molecule might still be there, but its spectral signature overlaps with methane, and the instruments might not be sensitive enough to tell the two apart at that distance. As one researcher put it, the signal from DMS and the noise from methane blend together in the data. K218b is our best candidate for alien biosignatures right now, and even here, we can't confirm anything. That's not a failure of the telescope. It's a reminder of how empty the results have been. Webb was designed to find this kind of evidence, and even with the most promising planet we've got, the answer is still, maybe. Probably not. We're not sure. The silence holds. So what explains it? Scientists and philosophers have been chewing on this for decades, and there are a few possibilities that are worth taking seriously. The first is called the Great Filter, a concept introduced by economist Robin Hanson in 1996. The idea is simple but terrifying. Somewhere between dead chemistry and a galaxy-spanning civilization, there's a step that is almost impossible to pass. A filter that virtually no species gets through. Hansen laid out 9 steps on the path from raw stardom to interstellar colonization. Things like the formation of habitable planets, the origin of self-replicating molecules, the evolution of complex cells, the emergence of intelligence, and eventually the development of technology capable of spreading across the stars. The Great Filter says at least one of those steps has to be absurdly unlikely. Otherwise, the galaxy would already be colonized. Here's the unsettling part. If the filter is behind us, meaning one of the early steps was the hard one, then we got incredibly lucky, and life is just astronomically rare. That's the optimistic version. But if the filter is ahead of us, it means civilizations like ours tend to reach a certain point and then destroy themselves before they ever make it to the stars. Nuclear war, climate collapse, engineered pandemics, artificial intelligence gone wrong. The possibilities are grim. And here's what makes this truly disturbing. If we ever find simple microbial life on Mars or Europa, that would actually be bad news for us, because it would mean the early steps are easy, which pushes the Great Filter further into the future and closer to us. The second possibility is that they're out there but choosing not to communicate. This is called the zoo hypothesis, originally proposed by John Ball in 1973 and actually anticipated by Russian rocket scientist Konstantin Tsiolkovsky in the 1930s. The idea is that advanced civilizations have detected us, but they're deliberately avoiding contact. Maybe they're studying us like we study animals in a nature reserve, observing but not interfering. Maybe there's some kind of galactic protocol that says you don't make contact with a species until it reaches a certain level of development. It sounds like science fiction, but it's a logically consistent answer to the paradox. If a civilization is millions of years more advanced than us, their reasons for staying silent might be completely beyond our ability to understand. We'd be ants trying to figure out why the humans aren't talking to us. The third possibility, and maybe the most sobering one, is the self-destruction hypothesis. The idea that technological civilizations are inherently unstable, that the same intelligence that lets a species split the atom or build artificial superintelligence also gives it the tools to wipe itself out, and that this happens reliably before any species manages to leave its home system. If this is true, then the silence isn't a mystery at all. It's a warning. The universe isn't empty because civilizations never arise. It's empty because they don't last. And that brings us back to Webb. The most powerful telescope ever built is showing us worlds with complex chemistry, planets with water vapor and carbon dioxide, moons that might have subsurface oceans. The ingredients for life seem to be everywhere, but the silence persists. Maybe we're early, maybe we're rare, maybe we're being watched, or maybe every civilization that reaches the point we're at right now faces a test, and the ones who fail leave behind nothing but silence for the next species to wonder about. Webb can't tell us which answer is correct, but it can tell us this much. The universe is vast, it's old, the building blocks are there, and as far as we can see, we are completely alone. Whether that's a miracle or a warning depends on what we do next. If you made it this far, you're the kind of person who actually thinks about this stuff. Subscribe so you don't miss the next one. We've got a lot more of the universe to explore together.